back to the basement. You know, when I was 18, like many people, I left home and went away to college. For me, college was in Delaware, and it was a 16-hour drive away from home. And I'll never forget my experience there. I'll never forget the events and the people who not only changed me, but really shaped me into the person I would become. And one of the key people in that experience was Dr. David Norris. Dr. Norris, Professor Norris at the time, not only challenged me with his information, not only expanded my perception and my horizons with the concepts that he presented, but he was also a sympathetic listening ear, a guiding hand, a person you could turn to with serious life questions beyond the academic. When I heard recently that I had the chance to contribute something that could be a convenience to him, and that more importantly would be a reminder to him of the appreciation of thousands of people like me for the influence he has exerted on our lives, I jumped at the chance. So what we're going to be going through together is building a library ladder. Now, we want this ladder to have a classic library look. As such, we'll be building it out of oak, out of solid brass, and we'll be making it in a way that is hopefully both classic and elegant looking, but entirely safe and functional. Let's talk about that. Now, I have here with us a couple examples of ladders that have qualities that I want this ladder to have. What this ladder has is the charm of its vintage heritage. This ladder's been around a long time. It was no doubt factory made, but it was sculpted from wood, and over the years it has had repairs made, additions made to it. And you can see that it has gravitas, it has history. And if you're a real adrenaline junkie, then this ladder can actually be a pleasure to use, because if you get up on this ladder, there is really no telling what it's going to do next. That is a characteristic I do not want the ladder that I build to possess. On the other hand, we have this ladder. Now this ladder is very easy to use. It is very stable, very confidence-inspiring, and even when you get up to its highest level and stand on this platform, you do not have any sense of fear. The ladder is stable. You have this brace you can lean against and hold against. It's easy to use. It's easy to fold and to stow away. So you ask, why don't you just ship him this ladder? Well, here's the problem. It has no class. It has no style. Shiny aluminum, well, it is what it is. But what it isn't is library. We're going to make a ladder that looks vintage, solid wood, brass, oak, but works like this. And that's what we're going to kick off this morning. Nice bull nose. The board is 3/4 of an inch thick, so we use a 3/8 radius rounding over cutter. This is a 5/16 diameter rounded tip box bit. And here is the tread pattern that we just milled into the face of this board. Alright, so the next thing to do is to cut the stair treads to their proper length. So the ladder is going to be tapered. The two side rails are going to taper from, this is the bottom, up to the top. And then the treads go in between. However, from a side view, it is at a 70-degree angle, and the treads are not angled. The treads are flat, parallel with the floor. We know that this tread will be shorter than this tread. But the question is, looking down at the tread, like this piece of wood, is it tapered? And secondly, what is this angle? Now, this angle you would just automatically assume should be in line with the taper here. that this angle should be the same as that angle. However, let's do some mental gymnastics and figure out whether this is angled here and how much this should be angled. So first of all, here are our two simulated rails. Now, when I'm trying to figure things out mentally using a mental picture, it helps to deal in extremes. So these two pieces are angled just like this sketch. And if I put this board between them, it lines up quite nicely. However, the board is actually going to be back at this 20-degree angle. It's going to be 20 degrees away from 90 degrees. So then the question is, does it need a taper? And the way to mentally answer that is to say, well, what if it were all the way rotated away from 90 degrees? And as you can see, as this board, as it rotates away from vertical and up towards horizontal, it has to have more and more taper. And the amount of taper is equal to 20 out of 90 times whatever the actual taper is between these two members. So this fraction of the straight up parallel angle, if I draw this straight up parallel angle right now, it's not going to be that entire angle. It's going to be this percentage of it, 20/90ths of it. So it's going to be somewhere back into here. We'll calculate that in a minute. Now, how about this angle? Right now, these two angles more or less correspond to here. The question is, does this change as this thing tilts back? And the answer can be found pretty simply. If we tilt it all the way 90 degrees away from this perfect vertical, now this interface right here, this is square straight up and down, and this is square straight up and down. So 0 angle here if it's all the way at 90 degrees. Well, how close to 90 degrees is it going to be? Well, again, it's 20/90ths towards that degree. So what we'll do is we'll measure the raw angle if it were perfectly vertical along with the side member, and then we will subtract 20/90ths away from that angle to get our final answer. So then the question is, what's our raw angle? Well, by measuring with a digital protractor, I find that our angle is 3.1 degrees from straight up vertical down. So this piece is going to taper inward 3.1 degrees, but we're only going to move 20/90ths of 3.1 degrees. 2.9 times 3.1 turns out to be 0.69 degrees for that angle right there. For this angle, it is 3.1 degrees, which is its natural angle, because it's going to line up with how this side rail is tapered upward. But it's 3.1 degrees backed off by 0.69 degrees. So 3.1 minus 0.69 is 2.41. So this angle here is going to be 2.41 degrees. So when we cut this will be a 0.69 degree cutoff, and the blade will be angled at 2.41 degrees. So in order to cut these consistently, I have tilted the blade over at exactly 2.41 degrees using a digital protractor. And then I've made this wedge to go in my sled. It's 0.688 degrees from here to there. So we will always cut it with the top side facing down, with the wedge in this orientation. Then the front goes there, which will give us the correct bevel back. And then with the wedge in this orientation, then this spins around. and comes up against the back of it. So by doing this, I get real consistent cuts, and they should all have the precise angle on the first try. And there we have 4 perfectly beveled, perfectly tapered steps. Okay, with the steps cut out, we're next moving on to these main rails of the ladder. I have already cut the first 20-degree bevel on the 2 boards, which establishes the foot of the boards, and it establishes this face is outside, this face is outside, and in between is now inside. And I've gone through and labeled them as such, out and front. I also have laid out the location of the center of the hole that we will use to cut that cove right there. It's a 2-inch hole, and the center of it is up here in what's free space on the drawing, but is in actual board before it's been cut out. So I will mount these up in the mill, drill a 2-inch hole here. I'll measure and mark, but there will be a 1-inch hole somewhere in this vicinity for the top rod to go through. And there will be a 1-inch hole for this bar here, and then these will be 3/8 holes down here at each step. So I'll get all these marked and plotted, and then mount this in the mill, the mill drill, and then I'll be drilling both at once so that I end up with 2 absolutely identical pieces. Alright, so here we are set up in the mill, and for anyone who's not familiar with it, we're using a tool here called a wiggler to accurately locate the precise point that we want to drill. Now the way a wiggler works is pretty low tech. It's simply in a ball socket here that I can bend. It's a tight fit, but it's not, obviously it's not impossible to bend. With the machine turned on, of course, it inscribes this big circle because it's not centered. But I can take my fingers and hold it to an exact center. Now because of the nature of it, see the top of it, notice, is a little bit out of round, but the point is perfectly in line with the quill of this machine. You also may have noticed that I've got a piece of paper in here between the wood and the vise jaws, and that is simply for the unglamorous reason that I do a lot of metal work in this vise, and getting it truly clean to the point that it's not going to stain this oak is very difficult to do. So I simply slip this piece of paper in here to protect the oak. So we'll chuck up a 2-inch bit and drill right there. Here we are set up to drill the 1-inch hole for what will be the top brass pipe. I have the part angled 3.1 degrees up into the fixture. The way that I measured the 3.1 is I measured from the fulcrum, which is the edge of the vise bed, to a point here where I drew a line on this block. Turns out to be 17.25 inches. From there, a little geometry, a little trigonometry tells me that the elevation, 3.1 degrees, the elevation at the 17.25 point is 15/16 of an inch. I cut a chunk of wood that's 15/16 of an inch thick, lined it up precisely at the line that indicates 17.25, and now this slope is precisely 3.1 degrees. This is the same setup that we'll use to drill the brass pipe that goes at this location for the fold down platform to rest on. Now for this hole, here's the pivot point, and this is the hole where the brass pipe will go through that the platform rests on. For this hole, it will be secured by a big brass escutcheon, a big brass plate that will screw into the wood and then engage with the brass pipe. So for this one, I need to first countersink the brass plate. So I have a 2 1/16 inch bit here. I will basically cut the brass to about 2 inches, to give it a snug fit into this recess. So my brass is 3/32 thick So I'm going to recess this about a 1/16 of an inch. And I'll use the digital Z-axis indicator to advance it another 1/16 of an inch. Alright, so now with my countersink finished, I'm ready to tilt it back up to 3.1 degrees and drill through it with a 1-inch bit. So now all the drill press work is completed on these. I have the recesses drilled for the rosette plates, for the rung tension, recesses drilled for the 1-inch brass pipe that will be going through, the recesses and the hole for the hinge point, the fulcrum point for the hinge, and then the curve cut in for where the rail will thin out at the top. So what we need to do next is do the saw work to thin the rails out at the top, and then go back with the router and round those edges over. So this cut we make with the table saw, with the blade set up as high as it can go so that we get close to a vertical cut face here. As you can see, just a little bit of work to clean up that inside curve right where the blade can't quite reach. Next we'll cut perpendicular across the top here, leaving half of that circle as a semicircle to hold the pipe. There we have it. Nice, rounded over. Alright, so the very final step is to dado the pockets for the steps to slide into in the side rails. Standard dado setup. I played with it and got it together such that it's making a nice tight slot. Because we're going to be doing these dados using the sled, now the astute among you may pick up that this sled is one of the very first shop jigs that I ever built. That me and this sled have been through a lot together. Nonetheless, it's square and it works. So, you know, if it ain't broke, don't fix it. Isn't that what the no, it was the clock on Beauty and the Beast. If it's not Baroque, don't fix it. Anyway, so these are going to be at a 20-degree angle. So we'll use the same angle template that we built just a minute ago. I'll have to play with it some and figure out if I'll do it at this angle or at this angle. Meanwhile, I'll take a test piece and work out the depth of my dado cut. The boards are 3/4 of an inch wide. The deeper you cut the dado, the weaker you've left the board itself. I don't know that there's necessarily a perfect formula, but to my mind, especially on oak, a registration depth of 1/8 of an inch is plenty. So then I'm going to fudge it a little bit towards more strength, and I'm going to set my dado depth to about 3/16 of an inch. So we'll take a cut, measure it with the caliper, and see where we're at. Alright, a 64th is too much. So, lean down here and move that by a 1/16 of a turn and lock it down. And that's going to be our final depth of our dado cut for the steps. Now the question becomes how, as we're cutting this slot on the bottom, how do we line it up from up here? And part of the answer is this alignment hole that we drill. This hole should be perfectly bisecting the edge of the blade. What I intend to do is, after the wood is physically assembled, I'll actually drill through here at an angle, and a brace is going to pass partly through the step material, partly through here, and lock everything together. So this piece should be lined up right on the edge of the slot. So I can actually use that hole from the top. So one of the things I need to do is I need to get this piece here perfectly flush with the edge of the cut. There we go. Alright, so now I can sight along here. And yeah, right now we're running right dead into the middle of that drill bit. And yes, we got very close to perfectly bisecting that hole. So now we simply do that 7 more times. Alright, so here it is with the steps just tri-fit in place. It's just being held together at the moment by friction because these dados are nice and tight. And I'm very pleased. Okay, having played with this thing a little bit, I've decided to go to the lumberyard and buy some more oak. Because, as you can see, I have all of these dados very neatly bisecting this line, just like on this side. However, if the astute among you will notice that I didn't choose the same side of the hole. The dado is supposed to be to the top of the hole, not beneath the hole. So the very first one that I laid out and aligned this with that edge of the dado was a mess, was wrong. So this piece right here needs to be recreated. It's especially frustrating when you mess up like this, especially when I have done everything else to the piece. It has been completely edged, it has had all of its holes drilled, it has had all of its countersinks created, it's had the revetment cut out at the top, and it's just very frustrating. However, I'm going to try hard to let go of the frustration, because if I burn and sizzle the whole time that I'm working on its replacement, I'm likely to mess up something else. So I'm just going to chill out. This is all part of the process. And head to the lumberyard and buy some more oak. Having spent a couple hours recreating this piece so that it actually matches the other piece, we're now ready to resume our regularly scheduled programming. First thing I want to do is get this assembled. It will be glued here into the steps, but it will also be held together in tension using metal, in this case steel covered with brass bracing rods. The bracing rods will penetrate through here and be drawn together with nuts. We will obviously need a hole here large enough for that metal to penetrate. But we're also going to need a series of brass rosettes. 1.5-inch rosettes to fit this location. 2 1/16 rosettes to fit this location. And I think 1 5/8 to fit there. Oh, and then 1 inch for the inside, way up here. The brass rosettes will be cut out of 1/8 brass plate. And then they will be cleaned up and I think dressed up using the metal lathe. So let's transfer over to the metal lathe and see what we can get done. First we have to cut out these pieces from the brass. Now normally when you use a hole saw, what you want is a hole in the base metal that you're going to put something through. But in our case, we're going to be using a hole saw because we want the plug that the hole saw creates. So I have measured the inside of these hole saws to see what kind of plug they're going to create. It turns out I'll be using these 3 hole saws to cut our slugs that we will then be turning down to a perfect size. I would recommend that anyone who's a serious maker gets a set of hole saws. It's impossible to predict what size you're going to need going into any given project. Anyway, I'll be using these 3 hole saws to cut out our various brass slugs. Alright, so here we have a nice pile of slugs. Hindsight being 20/20, I would have been smart to scrape this glue off of these before I cut them. But I'm not smart enough to have done that, so I'll have to scrape the glue off now. So in preparation for turning these brass rosettes, I have first chucked up this piece of cast iron. It's from a dumbbell from Goodwill. and I have faced this edge smooth, just a regular facing cut. I'm about to drill and tap it for 1/4 20, and then each of the rosettes will be held to the face with friction with a 1/4 20 bolt. From there we will hit its outside diameter and then give the face a bit of decoration. Alright, so now I have this hole tapped for 1/4 20, and of course each of my slugs has a 1/4 inch hole in the center. So that will locate it, and then I'll crank it down. For each of these slugs, I have chosen a side that's going to be flat and given it just a bit of a sanding. So the flat side, the clean, perfect flat side, will go against the mandrel that we've created here. And I simply crank it down tight. Now, this particular rosette is to fit the 1.5 inch pockets. The truth is they're more like 1502. So I'm actually going to make this about 495, 1.495. I want to give it about 5 thousandths clearance. It starts off life as 515, so all I'm going to take off is about 20 thousandths. So I'll begin just by getting it trued up to where it's a nice clean straight cut. And that will produce the size that I want, which, as we've just discussed, is $14.95. So now that I have the outer diameter properly set, I have ground this form tool out of this high-speed steel tool bit material, and this will give a decorative beading to the outer edge of these rosettes. I'm not trying to make them overly fancy, but I don't want just a big expanse of unimproved brass either. So what I'm doing is I'm aligning this to where the outer part of the ring is very close to the outer diameter. That looks pretty good. We're going to say the 34 mark. Lock down the cross slide, and all we're going to do is take this in until it has produced a nice little decorative bead on that edge. On these larger rosettes, a single bead is not adequate. So I did one at the outside, and then I scooted it over and did a second bead to the inside. Kind of bring the detail towards the center.